So in today's lesson, we're going to again look at a few more projectile motion problems. We'll do a couple more here just to make sure everybody has the hang of it. Or maybe we'll do a different color today. What do you think? We'll do blue. And these are all level to level. We're actually not going to get to the non-level to level, at least not right now. So here we're going to have two ships, a pirate ship, and I'm not going to spend a lot of time drawing them, and a gold-bearing ship. And it's going to shoot a cannon level to level to hit the other ship. So let's see what we can figure out. We know that the cannon can shoot at 70 meters per second and that the cannon shoots at an angle of 30 degrees. So whenever you have this information, most of the time your goal is going to be to find Vx and Vy because they're independent of each other. So Vx is 70 cosine of 30 degrees, and Vy is 70 sine of 30 degrees, doing the opposite and the adjacent, Vx and Vy. And then let's see if we get those answers like we have on the screen there. Cosine 60.6. And yeah, we should. All right, 70 cosine 30. Sorry, I hit it wrong in my calculator. Just so you know, 60.6 and 35. Now, it has the x component is greater, and that makes sense because it's only tilted up 30 degrees. It's going to go faster in the x direction. Now, to get the time in the air, we're going to first find the time up. Remember that we always split this into two pieces, the going up part and the going down part. And for that, we can use definition of acceleration. It's the easiest way. Now, once the cannonball is at the highest peak, it can't go any higher. It has no y velocity. That drops to 0. So if we do a little rearranging of this formula, we get, let's see, negative v initial, and the negative, we're going to take care of it in a second, over a. So time up is negative. Now, we have to decide which velocity. We have 3 of them. We're thinking about it going upward. Well, the direction of upward, the velocity that's in that direction, is the 35, divided by negative 9.8. So you'll see that our negatives will cancel, and we won't get a negative time. So time up is 3.57 seconds. The nice thing is this is symmetrical. Time up also equals time down because it's level to level. That doesn't work for non-level to level problems, but we're not thinking about those right now. So the total time in the air is 7.14 seconds. Now we need to know, well, how close does the pirate ship have to get to the other one? That's an X question. So the easiest way to do that is Vx is distance over time. The Vx never changes. So x is Vx times t. There's no acceleration in the x direction. And let's just review to see what we got here. 60.6 was Vx times 7.14. Now, 7 times 6 is 42, so I totally believe that that's 432 meters. I trust my math there. So it has to get within 432 meters, roughly 4 football fields, to shoot at the other ship. Now the peak height, that's a y issue, and the easiest way to do that, because that should be d there, is time independent. Since we're looking at the peak height, the cannonball's not going to go any higher at the peak height. So V final is 0. And you may remember all this from chapter 2. I hope that you do. Because it's really the same process. It's just we have to split it into x and y vectors first. Let's see. So the equation simplifies. And now I'll solve it for y. Basically, you're just swapping the a and the y. And again, we get that question, well, which velocity do I use? Do we use the x, the y, or the total? Peak height is a y issue, so we need the y velocity, the y component, which was 35. Leave the negative outside the parentheses because we want it to cancel, and that's where it belongs. So crunching it out on my number machine here. And yeah, I get 62.5 is the peak height. Now we're going to do a really similar problem. A long jumper leaves the ground with an initial speed of 12 meters per second. And we know the angle is 28. And we don't know any other information, so this is all we've got. One thing we do know is that it's level to level, that he's jumping down a field, and it's nothing crazy like that. So Vx will be 12 cosine 28 degrees, and Vy will be 12 sine of 28 degrees. Should be seeing patterns here. And these are the same kind of patterns you're going to need to do on the quiz next week. Or later this week, excuse me, later this week. And I'm just crunching out some numbers, and I get 5.63 meters per second. Now to get the time of flight, we're going to have to get the time up. Best bet is just plain old definition of acceleration. Now going up at the peak height, Vy is going to be 0. So just like we've seen before, the equation simplifies. Just swap the a and the t there. And the eternal question is, which v? It's the y component. We're thinking about up. Well, something going up is the y direction. So divide that by 9.8, and we get 0.57. Fine. That's only time up. It'll go up for 0.575 seconds, but because it's symmetrical, it'll also come down for 0.575 seconds. So to get the total time, no problem, we'll just double that. And we get 1.15 seconds. And that seems reasonable for a jumper. You're not going to be off the ground for more than a second. Now to get the horizontal distance, well, that's in the x direction. Vx is distance over time. Because there's no acceleration again in the x direction, so x is Vx over t. So we don't want the overall velocity, we only want the x component, which was 10.6 times 1.15 seconds, to get us a distance of 12.2 meters. And as always, if I seem to be going a little too fast, you can always rewind the video a little bit, go back with the slider or pause it or whatever you need to do. Or watch the whole thing twice if you're really bored. I mean, imagine that. Let's get the peak height. Probably peak height. Gonna use time independent. And again, at the peak height, V final will be 0 in the y direction. So that's what we get. And let's see, we want the y. So we'll do a little algebra. Just swap the a and the y it's the same as if you multiply and then divide. We don't want to spend a lot of time doing that. So let's see what we get. Now we need the v initial, but in the y direction, and I have to remind myself that was 5.63. All over 2 times negative 9.8. Oops, and I don't get to square it. And just eyeballing these numbers. 5 squared is 25. 2 times 9.8 is about 20. So it's roughly 25 over 20, or a little bit more than 1. But let's see. And it is 5.63, so those are real rough numbers. Yeah, 1.62, it's more than 1, but it's not as much as 2, so the numbers seem to make sense. Oops. Sorry about that. 1.62 meters. Now the vertical velocity that they hit the ground. Let's think about that. They're coming back down. And maybe we'll just use definition of acceleration. So acceleration is v final minus v initial over time, but it'll only be the time down. So in this case, the initial y speed is 0. Right, here's the person at the tippy top. Eating at the leg. So on the way back down, they're starting out at 0 in the y direction. They still have x speed. And let's see what we get then. V final is a times t down. Acceleration is negative 9.8. And the time down was 0.575. It's not the full time. We're only thinking about the time down. And I'm getting, yeah, negative 5.63 meters per second. Now, if we go back and check, that was actually their y velocity on the way up. They went up at 5.63, and they come back down and land at negative 5.63. It's symmetrical. And the reason that it's symmetrical is because it's a level-to-level situation.